This is lesson 3.3. We're going to talk about proofs with parallel lines. And to do that, we're going to be talking about ways to prove lines are parallel. So notice that we have all of these same relationships that we had of our theorems. We had a corresponding angle theorem, we had an alternate interior angle theorem, and so on. So now at the end of these words, we see the word converse. And what that means is we're switching the order of what we knew and what we're proving. So the theorems all started, if two lines are cut by a transversal and they're parallel, then the corresponding angles are congruent. So now it's going the opposite way. We're saying if two lines are cut by a transversal so that the angles are congruent, then the lines are parallel. So in this picture, if I knew that angle 1 was congruent to angle 5, then I would be able to say that line L is parallel to line M. For the alternate interior angle converse, I could say something like if angle 4 is congruent to angle 6, then those lines are parallel. Using the alternate exterior angle converse, if angle 1 is congruent to angle 7, then those lines are parallel. And then again, anything with the word consecutive has to do with supplementary. So if angle 4 and angle 5 are supplementary, then the lines are parallel. And for consecutive exterior, if angle 2 and angle 7 are supplementary, then the lines are parallel. So the only difference is before, when we knew lines were parallel, we would use theorem at the end of our and now if I'm proving lines are parallel, I'm going to use converse at the end. So for our first examples, we're going to determine if the lines are parallel based on the information in the diagram, and we'll explain our reasoning. So just like before, our first step is to identify what kind of angles are these based on their position. And now we're going to have an additional step. Do they fit the criteria for those angles for the lines to be parallel? So in our first picture, we see these two angles here, which are alternate exterior angles. In order for lines to be parallel, the alternate exterior angles have to be congruent. And if I look at these two numbers, they are. So this is yes, and it's the alternate exterior angle converse. In B, based on the location of these angles, these are consecutive exterior angles, which are supposed to be supplementary. So I'm going to check what is 132 plus 48 add up to. Oops, forgot to carry my 180. It does work. So these are in fact supplementary, so this would be yes by the consecutive exterior angle converse. For C, I have consecutive interior angles, which are also supposed to be supplementary. So if I check and add 125 and 65, I actually add to 190. So this is no, because they didn't fit what it should have been. So I'm going to say no, and I'm going to explain that the consecutive interior angles are not supplementary. So I'm explaining by saying I know what they were supposed to be, and I'm showing you that they're not. In D, we have a pair of corresponding angles, which are supposed to be congruent, and they are. So this would be yes by the corresponding angle converse. For E, these are a pair of alternate interior angles, which are supposed to be congruent, and they are. So this would be yes by the alternate interior angle converse. And in our last picture, we have a pair of vertical angles. And if you recall, vertical angles were something we learned back in chapter 1 that had nothing to do with parallel lines. It's not one of the 5 ways we just discussed here. So this is no, because vertical angles don't make lines parallel. Right? So I'm acknowledging that I recognize the relationship there, but I still know that that's not a way to say that lines are parallel. So here's some check-ins for you to try. You could pause if you like, and the answers are posted in the blank notes on Google Classroom. So now in example 2, we're going to look at example 2a and b. We're going to find the value that makes the lines parallel, and we're just going to state the converse that was used. So these two angles are corresponding angles, so we're using the corresponding angle converse. And I'm going to set them equal, just like I would if I already knew the lines were parallel. So now we'll solve. We get 3x equals 60, divide by 3, and we get x is 20. So example 2b, it might be hard to see the relationship because they use the arrow, but what we're looking at are angles here and here. So those are consecutive interior angles. So I'm going to say I'm using the consecutive interior angle converse. And consecutive angles are supplementary. So we're going to do 6x minus 30 plus 96 equals 180. Same side, same sign. So 96 minus 30 is 66. Take away 66. 6x equals 114. I'm going to try some mental math here, but I don't trust myself. So dividing by 6, we get x is 19. So here's some check-ins for you to try. Once again, the answers are posted on Google Classroom. So now we're going to look at a proof. So for this proof, we are given that angle 4 and angle 7 are supplementary. And we are given that angle 6 and angle 7 are supplementary. And I noticed step 2 also has the word given. I see that we are using the definition of supplementary angles, but I've also said here, my step 2, I've made those equal to 180, so that's going to be another definition of supplementary angles. And that means the ones we haven't mentioned yet are 4 and 7. So in step 3, I'll say measure of angle 4 plus measure of angle 7 equals 180. Step 5 says we're going to use transitive. So if I look at steps 3 and 4, both of them were equal to 180. So I can take the leftovers and make those equal. So that's going to be measure of angle 4 plus measure of angle 7 equals measure of angle 6 plus measure of angle 7. In my next step, I now have just measure of angle 4 equals measure of angle 6. And I had measure of angle 4 here, and I had measure of angle 6 here. Both of them did have a plus 7, and now that's gone. So we took it away. So whenever time we take away, that's the subtraction property. And now step 7 says we're going to use the definition of congruence. So if I knew that measure of angle 4 equals measure of angle 6, I can now say that angle 4 is congruent to angle 6 by the definition of congruence. And my last step, now that I know 4 and 6 are congruent, if I look in my picture where 4 and 6 are, those were alternate interior angles. So I'm able to say the lines are parallel by the alternate interior angle converse. So because this statement here had a parallel symbol in it, the reason here is going to have the word converse in it. So this is one last one for you to try. Pause it now if you'd like. That is the end of section 3.3.